Hey guys, what's up? This is Alex Duque, and we're talking about 3D fluids today. We're expanding a little bit more on what we talked about 2D fluids, and we're just gonna move one step further with, or it's more like an expansion really, of what you can do here. So I'm gonna make a 3D container, and this is non-dynamic 3D fluids, all right? So we're not talking about temperature or fuel or any of that stuff. As a matter of fact, we're gonna even take a different approach to fluids. Um, if I change the density to a gradient, then as you can see, my fluid is now a full fluid. And if I change the size, X, Y, Z, so make the size, let's make that, yeah, 10, 2, and 10, then what you can see happening here is that it's a flatter version of the fluid. So now that that density is a gradient, you can do any type of gradient within that, but we're going to keep it as constant. And now under the content details, when it comes to density, you can only change density scale, but if you change the buoyancy, it's not really going to do anything because it's not really a dynamic fluid. Now, this is all controlled via shading. So this is when it gets a little tricky because a lot of that simulation, once you actually do move into the simulation of fluids, a lot of that look is controlled by the shading. So I'm just going to show you a couple of things. Right now I can display as a volume, but I can also display it as a surface. And within the surface it can be a hard surface or a soft surface, and you can change some shading values here. It's not too many, but you can change a couple of that. But we will get into that hopefully within class, or you can just experiment and you can get some pretty interesting results with this, guys. And then you have again the shading, and under the shading right now there's a color, and that color is set to constant, but again I can change the colors so that, let's say, it's make it a little bit like a dark or desaturated version, and let's make this a little bit blue. And right now it's set to constant, but if I made it, let's say, a Y gradient, then you can see that at the top it's got one color and at the base it's got another color, and you can keep adding colors even, so this gets even a little bit darker, and you can even make the top maybe a little bit more yellowish. So doesn't look like much, but with this principle you can actually map textures, and it's not like you can drag and drop a texture in here. It's all about noises. There's Perlin noise, there's billow noise, there's volume, wave, wispy, and space-time. These are all mathematical equations, but you can map them to the transparency. So just map that into a transparency, and as you can see, we can't really see much because I need to press 6 so that I can see something. And there it is. There's a little bit, but not too much. But there it is. Now there's a threshold, an amplitude, and a ratio, and a frequency ratio, and a maximum depth. As you can see, as I go changing this, then you can see you start seeing some clouds going on in there. And remember, this goes hand in hand because we're mapping opacity. This goes hand in hand with the opacity. So if I were to make this more like that, then you can see what's happening there. I can even make it more like that. So you're not you have to go back and forth. You can also change the input bias if you want, so you can always adjust your look. And what I'm going to do here is try and play a little with this value, change the ratio a little bit more and the frequency ratio. So now I got a little bit more clouds. Now see all these voxels? I'm actually seeing all those voxels there. That's because there's an option under content, let's see, under display, it says slices per voxel. So per every voxel there's 2 slices. If I have more slices, then for display purposes I can get a better idea as to what's happening. Now remember, you want to keep your voxel square, and what's happening right now is it's not, because I know I have 10 divisions, 10 divisions, and 10 divisions, but this is only 2. So if I were to look at just change the boundary draw to reduced, and you can see what's happening on there. This has more and this has less. So let's just balance that out. Make that 20 to 24 and 20. So they're all square. And you can see a little poof of clouds over there. And again, you can go changing these settings. So back to shading and back to textures. So the rest is really just playing with these types. You can try billows as well. Billows are pretty cool for clouds. And let's just change the texture scale. And you can change the billow density and a little bit of size random. And if you play good with these values, you can actually get some pretty good results. It just sometimes takes a little bit of time to get to it. But you can see I got some interesting poofs of cloud there. And there is sort of like a self-shading to them, or like a self-shadowing, without having the need to do ray trace shadowing or anything like that. So like I said, these guys are pretty cool, and it just takes a little bit of experimentation and understanding those noise algorithms. But once you get them, you can get pretty cool things. I'm gonna keep it there, I think. That way we're not gonna I can do a little bit more self-shadowing under lighting, so you can see that, and you can change that opacity. You can even have real lights or not, so that self-shadowing can also be based on an actual light that you have. And under render stats, you can tell them to cast or to receive shadows, and you can make them visible in reflections or refractions. Now, fluids are a little bit expensive to render, so you gotta keep in mind you want to keep it light. Now, just go ahead and save this scene. We'll call this basic cloud. But if you want to understand a little bit more about how to make clouds, again, you can always go to the visor, get fluid example, and you'll see clouds. And if you just drag and drop some clouds in here, let's do sunset clouds, and you can see an example there. This one's using 2D fluids, one for atmosphere and another one for the actual particles. And again, if you open up the attributes, then voila, you got yourself a good explanation of what's happening and how they're changing everything, so you can understand a little bit better how those noise patterns are working. So anyway, I hope that you found this tutorial helpful. It takes a little bit of experimentation, but you can do pretty interesting things. As a matter of fact, you can even, once you have this painted on there, you can make it dynamic and then have an object go through those clouds and actually distort them. One more thing that's good to note is you can animate those textures. So if I come here to the texture stat for a second, right now this is using a Perlin noise, and texture time is the time of the texture. So as you can see, if I start moving that, then it start moving around. So that's kind of helpful. You can even write a little script for this because it's time. I can make a new expression, and that's going to open up the expression editor, and I can just copy this and paste it. It says cloud layer shape attribute is texture time equals time. Create. So now they're automatically going to be moving. It's like setting a keyframe without having to set a keyframe. And you know, if it's moving too fast or too slow for you, you can always edit the expression, and I can do time divided by 5, for example. So now it's moving a lot faster. Or on the opposite side, I can do equals time times 40, for example. And then that's going to multiply the time times 40, so it's going to move really fast. Or you can do it equals, instead of time, you can do it equals frame. So that means it's going to change a lot faster, 30 times faster actually. So anyway, it takes a little bit of experimentation. You don't necessarily need to make an expression. You can always just set a keyframe and then set another keyframe. So it's not like, oh, I need to know script. No, you can just do this by setting keyframes if you want. The rest is really just experimentation. So anyway, I hope you enjoyed this tutorial, found it a little bit helpful, and start playing with clouds. See ya. Bye.